problem number 33. So this is saying that LM is a midsegment of this quadrilateral ABCD. And so here's what we know about midsegments. In this case, this is probably a trapezoid. Okay, midsegments are always the average of the bases of a trapezoid. So what that means, here's a simple example before we get to this algebra. If I call this one 8 and I call this one 20, if I add up these two pieces, 20 plus 8, and I divide it by 2, in this case that's 28 divided by 2, I know for sure that LM is worth 14. All right, so that's the idea. Add them up, divide by 2, and you should get the midsegment. So we're going to do that, but we're going to use algebra instead of using just regular old numbers. Okay, so for our problem, AB is x plus 8. So if I add together x plus 8 plus DC, which is 250, and I divide this by 2, I should get the midsegment, which is LM, which they told us that's equal to 4x plus 3. Okay? So to solve this, I'm going to first simplify the top. This now says x plus 258. And I'm going to multiply this 2 over to the other side. It's going to look like 2 times 4x plus 3, which we can distribute. So this says x plus 258 equals 8x plus 6. And now I just got to sort out the x's and the numbers. I'm going to subtract this x to the right. It's just going to say 7x. Okay? And I'm going to subtract the 6 over. It'll say 252. Okay? So if I divide these, it looks like I get... let me grab... Okay, I'll bring it over here because I'm running out of space. Okay, if I divide by 7, I'm going to get, it looks like 30, and then if I have 3 left over, I'm sorry, 4 left over, a 6, right? So 36. So x is equal to 36 when you divide both sides by 7. So again, knowing this rule about the mid-segment being the average of the bases will help you to find that. Okay. Problem number 34, distance formula problem again. You were given that in video number 1. If you don't have it, you can look it up. I'm just going to go right into using it. So the distance between 2 points is equal to subtract the x's. So if I call this x2 and y2, and this x1 and y1, it doesn't matter in which order you write them, just as long as you're consistent. So I'm going to say, in this case, 9 minus 8 squared plus 1 minus 3 squared. And it asks us for our answer to be to the nearest tenth, so we're going to just note that as we go. So this says 1, right? 9 minus 8 is 1 squared, which is 1. And then 1 minus 3 is negative 2 squared, which is 4. So this is the square root of 5, which since they asked for the answer to be to the nearest tenth, I'm going to go to my calculator. I'm going to type in the square root of 5, which is 2.2 rounded to the nearest tenth. And that would be the distance between those 2 points. Okay. Problem 35 is asking us to find the values of x and y. So again, right away what I'm noting is I'm seeing 30 and a 45. I'm just going to fill in the rest of these angles. This one's a 60, and this one's also a 45, and a 90 down here. All right, and now I'm going to look for sides that I have information about, and really the only side I know about is the 34. So I'm really going to work on this 30, 60, 90. And the rules for 30, 60, 90 say that if the hypotenuse is always double the short leg. The short leg's across from the 30, so that means that this little line in here has to be worth 17. Okay? The long leg is across from the 60, and that is always the short leg times the square root of 3. So right here I'm going to say the short leg was 17 times the square root of 3. That goes there. Okay? So now I've filled in all the information for the 30, 60, 90. I haven't answered any of their questions yet. I don't know x or I don't know y, so I'm just going to keep going. I'm going to look at this 45, 45, 90, and I'm going to say, well, what do I know about those? Well, in 45, 45, 90s, the legs are equal. So if this leg is 17, this one is also 17. Okay? And then the hypotenuse of that is always the short leg, or the leg, because they're equal, times the square root of 2. So I found one. X is equal to 17 times the square root of 2. And y is equal to 17 plus 17 times the square root of 3, right? These two little segments. So I'm not going to type these ones in the calculator just to save some time. It did ask to the nearest tenth, so make sure you go to your calculator and do 17 times the square root of 2. And you also do 17 plus 17 times the square root of 3 and get those values. That's what you'd be expected to find. Okay, problem 36. Again, here's another 45, 45, 90. I'm just going to leave them in radical form. It does say decimals, but again, just for the sake of time, the legs in 45, 45, 90 should be equal, so this one's 6. And then this one is just going to be 6 times the square root of 2, which again, you can go to your calculator, type that in, and get the value to the nearest tenth. Problem number 37 is asking for the area of the shaded region, and we've done one like this before. So we're going to find the area of the sector, and then subtract off the area of this triangle. So let's start off with the area of the sector. Area of a sector will be provided to you. It is arc over 360 times pi r squared, which would be 24 squared pi. Right, so this is representing 12 over 36, which divides again to 1/3. So I'm going to say 1/3, okay, and then 20. Let's find out what 24 squared is. So 24 times 24 is 576, and then if I take a third of that, okay, so let's do the 576 pi. Okay, so if I multiply that by a third, which is the same as dividing by 3, I get 192 pi. 192 pi. And so if I shade all that in, what we just found is the area of basically all of this, right? The shaded region and the triangle all together. So what we want to do now is we want to subtract off this triangle with the 120 at the top, because that's not actually a part of the shaded region. So I'm going to draw the triangle so we can label it. And this has a 120 at the top. Oop, let me grab my right pen tool. All right, so I want my pen. There it is. Okay, so I have a 120. And then they tell us that one of the sides is 24, and the other one's also 24 because it's a radius of the circle. So it looks like I have an isosceles triangle, and across from this 24 and across from this 24 have to be equal. And I have 60 remaining degrees that I have not used, which means they have to be worth 30 and 30. Okay, so I'm going to actually erase this 120 now, because I'm going to draw in an altitude, or a height. We're going to say a height is going to split that 120 into 60 and 60. Okay, so if I'm going to find the area of this triangle, let's start with the formula. Area equals 1/2 base height. I don't know either of those right now, but I can find them very easily using 30, 60, 90s. I'm going to say, well, the short leg is the 24 cut in half, so that's 12. That's my height. So I'm going to say 1/2. Let me move down some more for you. Okay, 1/2. The height's 12. And the long leg is going to be, if this piece right here is 12 root 3, and this piece is also 12 root 3 for the same reason. They're identical triangles. That them together, the base is going to be 24 square root of 3. So let me give myself a little bit more space. Okay, so this base is the whole way across is 24 square root of 3 times 1/2. So I'm going to say this looks like 144 times the square root of 3 is the area of the triangle. So remember, let's go back to the context of the problem. I was doing all that work so I could remove it from the 192 pi. So my final answer is 192 pi, the circle, minus the 144 square root of 3 that we got from the triangle. This would be the exact area of the shaded region, which means we're not rounding. We're leaving pi's and radicals in our problem. All right, problem number 38, the area of the regular polygon. So in this problem, regular polygons are 1/2 AP to find the area. Okay, and I'm going to draw in, well, P is easy. Let's just do that, because that's 10, and this is an octagon, so this is 10 times 8 gives me a perimeter of 80. So what I don't know is the apothem, right? The apothem would be from the center to the middle of one of the sides at a right angle. And if you notice, what I just made here is a right triangle, and this 10 is going to become 5 and 5. So I can just do the Pythagorean theorem here. I could say 5 squared, we'll call this one A, okay, plus A squared equals 13.07 squared. Okay, so if you solve this, and I'm not gonna again show all the work for solving the Pythagorean theorem. You should be able to do that. Okay, I'm gonna get, it looks like 12, a little bit bigger than 12, 12.08. So I'm gonna say A is 12.08. So if I come back up here, my A in my 1/2 AP is 12.08 times 1/2. Okay, and so I'm just going to multiply all this out now, and I'm going to say 0.5 times 12.08 times 80. 483.2. So I would say my final answer for this one's about 483.2, and my units would be square inches. So I'll just put it down here, inches squared. All right, next problem, 39. Okay, so this is a find the value of the missing side, and it looks like we have to use sine, cosine, and tangent again, so let me label sides. This is the adjacent leg, and this is the hypotenuse. So that would be cosine, based on the information, of 20 equals adjacent over hypotenuse. So again, here's that situation where I'm going to switch the diagonals and say x equals 13 over cosine of 20. And then after that, again, be sure your calculator is in degrees mode. We're going to say, go to the calculator, 13 divided by cosine of 20. The cosine of 20 is about 0.9397. And so I get 13.8 rounded to the nearest 10th. 13.8. And that's good because that's larger than the side that we gave us, and the hypotenuse does have to be larger, so that makes sense. All right, problem number 40. We're identifying a pair of alternate interior angles. So interior is this space here. So I'm going to restrict myself now to 3, 8, 7, and 4. Alternate means on opposite sides of the transversal, and so I'm going to say this one and this one would be a pair of alternate interior. Your other possibility, you could have said also the 8 and the 4 are alternate interior. And just to remind you, alternate interior angles should be equal to each other. So we can say 3 and 7 are equal, and 4 and 8 are equal as well. Problem 41. Find the area of the shaded region. Leave your answer in terms of pi. So again, this is that whole idea that let's find the area of the big shape, which in this case is a circle. So the area of the circle is pi times 5 squared, which is 25 pi. Okay, so this is everything. And now we need to remove all of this white space. And you can look at this and say it's a diamond, it's a square, right? But what I'm looking at is I'm just seeing two triangles. And here's why I like this. If this is the diameter of the circle and it's 10, that means that the radius of the circle is 5. We just used that. And I could draw that radius straight up, okay, and make a right angle. I know that the height of this triangle is 5. So I'm going to say the area of this top triangle is 1/2 10 times 5. Well, that's half of 50, which is 25. I have a duplicate situation going on down here. This is also 5 with a base of 10, so that's going to be another 25. So I'm going to say the area of the white space is 50 that I need to remove. So I'm going to say 25 pi minus 50 represents the area of the shaded region. Okay, you could have also used what you know about squares and the diagonals of squares and 45, 45, 90s and found the area of the square that way. But I saw this triangle and that saved me having to do work with radicals, and that seemed better to me, so I went with that. Okay. Problem number 42. It says, can segments with lengths 8, 12, and 4 root 5 form a triangle? So let's answer that one before we go to the second one about what type of triangle is formed. Okay, so in order for a triangle to exist, it has to have the two shorter legs add up to a number that is larger than the third leg. And so when I see this 4 root 5, it's kind of throwing me off a little bit because I don't know if that's bigger or smaller than 8 or 12. So I'm going to say 4 times the square root of 5. Let's turn that into an approximate number. It looks like that comes out to be about 8.94. So this is 8.94. And so what we have to do first is check that. It looks like the largest side's 12. That 8.94 plus 8 has to be bigger than 12, and it definitely is. It's 16.94. So I'm going to say 8 plus, if you want to show work, 8.94 is greater than 12, so yes, it is a triangle. Okay, and now to check what type of triangle it is, here are my options. Okay, I could get an acute triangle, I could get an obtuse triangle, okay, and I can get a right triangle. Okay, so acute happens when the hypotenuse is, backwards sign. Okay, the hypotenuse is less than, okay, the other two sides in the Pythagorean theorem. Okay, and then if I use the Pythagorean theorem and I find out that the hypotenuse squared is greater than, that would be obtuse. If I find out that both sides are equal, that a squared plus b squared equals c squared, then I would say that they're equal. So let's check. So I'm going to say my a is 8 squared. Okay, I'm going to use the exact version because we're going to see we won't get a decimal. So 4 square root of 5 squared. And I need to compare that and put one of these three signs and compare that to 12 squared. So 8 squared is 64, okay? And then this is 16, right? When I square 4, I get 16 times 5, and this is 144. Well, 16 times 5, it looks like is 90, right? So this is, 80, right? So 64 plus 80. How is that related to 144? Well, it is equal to 144. And so I'm going to say that means that this has to be a right triangle. It's a triangle that exists, and it is a right triangle. So use the non-squared version to check to see if it is a triangle. Use the Pythagorean theorem version to check to see what type of triangle. Problem number 43. It says find the length of the missing side. This is, conveniently enough, also the Pythagorean theorem. So 7 squared plus, I'll just call this one x, so we have something to plug in. X squared equals 13 squared. And so this is 169, and this one's 49. And so if I subtract the 49, I find out that x squared is equal to 120. And it says to leave your answer in simplest radical form, so we need to find the largest perfect square in 120. This breaks down to, when I leave it as the square root of 120, okay, it breaks down into the square root of 4 and the square root of 30. So I'm going to say in simplest radical form, 2 square root of 30 is the length of my missing side. Okay, problem 44. Okay, they are saying the measure of the vertex angle of an isosceles triangle. So I'm seeing a problem with a lot of words and no picture. So the very first thing that I'm going to do is draw myself a picture. Okay, and they said that the vertex angles is 80 degrees. So here's what you need to know. When I draw these two equal sides, the vertex angle is the one in between them. Okay, so what is the measure of a base angle? Well, if this is 80, that leaves me 100 degrees left to split evenly between my two base angles, which are equal. So they have to be worth 50 and 50. So the answer to their question, what is the measure of the base angle? It is 50 degrees. Okay, problem 45. We got 2 more to go. The volume of a cube if the measure of a diagonal is 6. Okay, so cubes have faces that are squares. So I'm going to draw a square so I can label it. Okay, so here's my square. So they're saying the diagonal of a face, so the diagonal of one of these squares is worth 6. So let's say this is 6. Okay, so we need to find the area, I'm sorry, not the area, we need to find the length of one of the sides of these squares, because volume, what we're ultimately trying to get at is length times width times height. And for a cube, those are all the same. So I just need to find out what one of these sides is worth. So again, what happened is a square had a 90 here, but we broke it up into a 45, 45. And it looks like I have a 45, 45, 90. So one of these sides, which I'll call S, is worth 6 over the square root of 2. But I'm going to rationalize that. Multiply the top and the bottom by the square root of 2. And that's 6 square root of 2 over 2, right? Square root of 2 times the square root of 2 is the square root of 4, which is just 2. And so all said and done, it looks like I have 3 square root of 2. So one of these sides is 3 square root of 2. So to find the volume of this, I'm going to do length times width times height. And they're all the 3 square root of 2. So it's 3 square root of 2. Oh, I said 2, but I wrote 3. Okay, 3 square root of 2 times 3 square root of 2 times another 3 square root of 2. Length times width times height to find volume. And so the question might be, well, how do I combine 3 radicals using multiplication? Well, same way you would with regular numbers. If I said what's 3 times 7 times 9, you would first combine the 3 and the 7, get a 21, and then multiply that answer by 9. We can't combine them all in one step. So I'm going to do the same thing. I'm going to say 3 square root of 2 times 3 square root of 2 is 9 square root of 4. Well, 9 square root of 4 is just 9 times 2, which is 18. So I'm not going to say the first pair of 3 square root of 2's multiplied and give me 18. And then I'm going to multiply that by the last one. Sorry, that's supposed to be a 2. Keep doing that, okay? 3 square root of 2. And so if you multiply these together, it looks like you get 54. So my final answer is 54 square root of 2. And let's get units. Okay, inches cubed for volume. So the volume of the cube. I had to work to find how long were one of the sides using what I know about squares. All right, here we go. Last problem. Given right triangle ABC. So I'm going to pause right there and I'm going to draw myself right triangle ABC. Here it is. Okay. And then they specify to me that it has acute angles A and C, which means the right angle is B. Where you place the A and the C doesn't really matter. Okay. And so they're saying sine of C is 5 over 13. So if you remember that sine of anything is the opposite from C over the hypotenuse of the triangle. Okay. So I'm going to say opposite from C would have to be, in this case, if I'm doing the 5 over 13, the 5 goes opposite, and the 13 is the hypotenuse. And then I can do the Pythagorean theorem and figure out, and I'll let you do that this is 12. Or you remember that a 5, 12, 13 is a triple. That's what I actually did. Right? So if you don't remember that this is a triple, just use what you know about Pythagorean theorem and find that. So now they're asking for the tangent of A. So from here, this is opposite, this is adjacent. So the tangent of A is opposite over adjacent. So the answer to their question is 12 over 5.